Hey, today's our review day. So I want to talk here first about the test description, kind of the kind of problems that you'll be expected to be able to do. So the first question, how are they? Why are you eating them? Why when someone says these are so gross, are you like, well, let me eat that?
It's magic today.
Yes, they are.
No.
Maybe it's just the one I had.
All right,
No, they're really.
let's restart here. So you have one question where I just give you like the function. I'll ask you to identify the values for A, C, H, and K, and then to describe the transformation going on. So like reflection, stretch, shrink, shifting left, right, up, down. So on your note card, what would you want to have?
How to find the transformation.
I would definitely want on my note card like the general form for sine cosine. So like the A sine 1 over C times x minus h plus k thing, right? I want that on there. And I want the criteria for the transformations, if I don't remember that, which we probably don't, but that's okay. That's why we're putting in a note card, right? So like if the A is greater than 0, there's no reflection across the x-axis, but if like the A is less than 0, there is a reflection. I'd want that information, right? Because that's a lot of stuff to remember. The next two questions say give the values for A, C, H, and K, and then figure out the amplitude, midline, period, and frequency. So for that problem, I should already have the general form because I wrote that down already for the stuff for problem 1, but I would definitely want my formulas on how to find the amplitude, the midline, the period, and the frequency, right? Like the amplitude is the absolute value of A, the period is 2 pi times the absolute value of C. I want that stuff written down on my card so that I don't have to memorize those formulas. Everybody's cool with that? Okay. We'll have one question where I ask you to construct a sinusoid from a description. That was like what you guys did in worksheet 4. So I would probably include an example or two on my note card for something like that. That feels like a problem where just having an example would be the most helpful, right? One question where we construct a sinusoid from a graph. Again, that was like worksheet 5, I think. And an example there is probably going to be the thing that's going to be the most useful to us. Since the other things we use are just like using the definition for amplitude and midline and stuff. And then 3 questions where I ask you to graph sine, cosine, and tangent functions. The key points would be provided for you. It'll be like the same format as on the homework quiz, where I give you the list of key points that you're transforming. What thing would you want to make sure that you have for C, though? What formula needs to be there? Right? You definitely need that so that you make sure you do your transformation correctly. Right? That formula tells you how to transform the parent function into the resultant function. You definitely want that on there. And again, any extra space after I get those kinds of things on my note card, what am I going to fill with? Example problems, right? The things I feel the worst about are the things I'd want the most examples of, right? And I wouldn't necessarily just be working on like even copying straight from like answer key examples, but like include in some stuff for you, explaining to yourself like what it is that you're doing. So if the problem's a little bit different, than maybe the example that you wrote down that you're still able to kind of adapt. You know what I mean? There is no restriction on what you're putting on your note card. So like, you can be creative. You can really include some narrative for yourself to explain how to do a problem if the problem is a little bit complicated or difficult for you. Does that feel okay, guys? We have a good picture of kind of what we'd want to record.
Yes.
So I want to do a couple of, yeah.
Did you say the last question was like worksheet 7?
Yes. Yeah. So they'll be formatted just like the homework quiz was.
Okay.
Remember the graphing problem on the homework
Yeah.
quiz?
Yep.
It'll be formatted just like that, where I give you the key points and then ask you to fill in the blanks.
Giving us 2 points, or giving us 2, or 3, sorry.
It was 5,
Okay.
right? They give you 5 key points and then you're
one on
transforming.
the
The
front.
graphing, yeah, the graphing problem.
Yeah.
Yes,
Sorry.
that's okay. But you'll fill in the values for that into the formula and then grind through the formula to get your points.
Okay.
So is this that, like the note card?
Yeah!
Okay, cool.
Yeah, that's been typically the, the standard. Does everybody feel okay about what to expect for the test?
Yeah.
Okay. Are there questions? Are there things that you'd like to talk some more about? Okay. I want to point out a couple of things here that I saw on the homework quiz. Let's say we have something like this. Being able to identify the values for A, C, H, and K here is critical for this problem, and these problems. You cannot get those right if you're screwing that step up. I saw a lot of people having problems here. So let's go through this one more time. So what's the value for A there? 3, right? So the thing that we're looking at would be the general form. Everybody's okay with that? All right, what's C? Okay, so Nate says let's factor out the 2. While we do need to do that, that doesn't really change what we're going to get for C. But what is C going to be? I know 1 over C is 2. So what's C? 1/2, the reciprocal, right? If I know 1 over C is 2, if I flip 2 and I flip 1 over C, I get C is equal to 1/2, right? Is that okay? What's H? Close.
2.
Positive 2. Remember that the sign here is a negative sign, so the H is going to be the opposite of what it looks like in the formula. And then the K is 1. Okay. I saw lots and lots of problems getting those 2 values correct on the homework quiz. So to get the H, you have to make sure you factored, if necessary, and then you have to remember that coefficient on X doesn't give you C directly. the reciprocal gives you C. Okay? Like I would make a note of that on my note card when I do an example problem of something like this and just be like, hey, reciprocal dummy, so that when I'm looking at my note card, I hopefully don't forget to do it then.
What do you mean by that exact statement? Like, it's not the reciprocal, or it is?
So,
What is exactly?
so
like in this problem?
would the 2 isn't C.
Okay.
1 over 2 is C.
So you're just like saying how you have to put it over 1.
So that
Is
you I have to
what you're
take
talking about? Or 1
that
over it?
that coefficient, the reciprocal of that is C.
Okay.
That's what I'm talking about.
Okay.
Yeah, very, very, very good. Be specific, right? If you're not sure what I mean, like ask a follow-up. There's no problem there. Okay? The other thing that I saw on the homework quiz is I saw lots and lots and lots of us have trouble multiplying and adding with the fractions involved. Can we take a moment and do like a little example of this? Is that okay? So let's say C is 1/2, A is -2, H is pi over 4, and K is 5 or something. So the transformation map that we write should look like this. So when I fill that in, that's 1/2 x plus pi over 4 -2y plus 5. Everybody's okay with that? Once you've done that, you'll take that and you'll use like your key points that Mr. Kulik will provide. And you'll transform those using that map that we just made. Okay? So what am I going to do here? I'm going to take the x and plug it in. And then I'm going to take the y and plug it in. What's 1/2 times 0? 0. What's 0 plus pi over 4? Pi over 4. What's -2 times 1? -2. What's -2 plus 5? 3. If you're not sure, can you double check those things on your calculator? Sure. What's the thing you have to be careful about? If you do like 0 plus pi over 4 on your calculator, what's it going to give you? A decimal. Just check to make sure that that decimal is the same as pi over 4, and it's fine, right? So for example, if I'm like, oh, is 0 plus pi over 4 equal to pi over 4? I'll do pi over 4 in my calculator, or 0 plus pi over 4, and then do pi over 4, and see they're the same decimal, right? So those two guys must be equal. You know what I'm saying? Let's do the next one then. Everybody's okay with what I did there? Again, I'm just plugging in for the x and then plugging in for the y, right? Just doing the same thing over and over again. What's 1/2 times pi over 2? How do we multiply fractions? Straight across. 1 times pi is pi. 2 times 2 is? So that's pi over 4. What's pi over 4 plus pi over 4? How do we add fractions?
You make sure they have common denominator.
They need to have a common denominator. So pi over 4 plus pi over 4, are we good? So we get 2 pi over 4, which reduces down to pi over 2. Is everybody okay with that? And then negative 2 times 0 plus 5 is? Negative 2 times 0 plus 5?
Oh, 5.
5. There you go. I said it fast. But it was written down, so I was like, I can motorboat through that. Apparently not. Is this feeling a little better? Just kind of reviewing some of this, like details? Okay, we'll do the next one. Yeah, it's... Oh, is it not in there right now? Okay, I'll get it in just a second. My apologies. Let me do that right now while I'm thinking about it, huh? All right. Let's, Lucas, that stuff's in there right now. If you give a minute, it should sink in for you. Let's finish this one up then. What's 1/2 times pi? We think about that as pi over 1. So when we multiply the fractions together, you have 1 times pi over 2 times 1, 2. So pi over 2. Pi over 2 plus pi over 4. Okay, good. So this was pi over 2. So we need a common denominator. So 2 pi over 4 plus 3 pi or plus 1 pi over 4 is 3 pi over 4. Everybody's okay? Negative 2 times 1 is, or negative 2 times negative 1 is?
2.
Plus 5.
7.
Great. Get you guys out of there. One half times 3 pi over 2. Three pi over 4. Everybody agree?
Yeah.
And 3 pi over 4 plus 1 pi over 4 is? 3 pi over 4 plus 1 pi over 4 is? 4 pi over 4, which is the same as? Pi over 1, just pi, right? Then negative 2 times 0 plus 5 is?
5.
5. Is this feeling any better? I saw a lot of fraction struggles, it seemed like. Right, because you can get a lot of hairy fractions in here. It's no big deal, though. It works the same way, whether there's a pi in there or not. You been doing this since, I don't know, what, 5th, 6th grade, adding and subtracting and multiplying fractions. You should be able to remember how to do it, even if it's not like immediate. Should come back quick. All right, 1/2 times 2 pi. What's 1/2 times 2 pi? Nope.
No, 2 pi over.
Be 2 pi over 2 or just pi. And pi plus pi over 4 is? Five pi over 4?
Oh, it's adding.
Right, we're adding. If I'm doing that, I think about pi as 4 pi over pi, or 4 pi over 4. Right, just making a common denominator. And then -2 times 1 plus 5 is 3 again. Does that feel okay? The point of what we're doing here was just kind of reviewing this piece and how to do these arithmetics, because that seemed like it was a problem for some of us, which is okay. I'm happy to review it. I'm going to leave you alone now, let you guys get after some stuff. The review is now up there. My apologies for not having that up earlier. I thought I had it in there already. Yeah. Sometimes you can't talk, and then you also make mistakes. I feel like I might be coming down with a little bit of a cold here, so like in addition, like my tongue feels kind of swollen or whatever, so you feel like you talk. Do that while I'm thinking about it. All right. That's it for me. If you guys have questions on anything, feel free to come up and ask. If you want me to look at your note card or help you with your note card or whatever, feel free to come up and ask. When you're finished, we're just going to turn our note cards into the file here on my desk. I'll hold on to them for you till test day. Everybody cool? All right. Or if you need Delta Math help, again, I'm happy to help with that. Depending on how far you got, some of those ones at the end are like kind of tricky to figure out what is this asking me to do. Okay.